Guys, I don't know how much open-minded you are, but for me, it's beautiful. Look at this.
Hi guys, in this video I will build a liquid cooling system that can work closed loop but can also take the water from my well to cool down the CPU. First of all, the circuit. This cooling system can work in three different modes. This is the classic closed loop, quite easy. The water drain the heat from the water block and exchange it with the radiator. As you can see, there is no radiator in this circuit. I didn't want to put any radiator and instead I put a huge tank, and I wanted to see if a tank like that can stabilize the temperature of the water. The second mode is an open loop. The water comes from outside to cool down the CPU, and there is a continuous flow of cold water. This mode is supposed to work with a water well. In this way, I can send the water back to the well and avoid wasting any water. The major benefit from this mode is, since the well is underground, the water is cold no matter of the ambient temperature. I also did a third mode, the hybrid mode. Basically, at the beginning, I just wanted to build an open loop and experiment something with it. But then I thought, this thing will be really useless once I'm far from another outlet. So I implemented the closed loop as well. After that, I had everything I needed to do the hybrid loop. But what is it? This mode have three different phases, and I use the valves to deviate the flow of the water. It's basically a closed loop, but when the temperature reaches a critical threshold, the system switches to phase 2. In the second phase, one of the two valves turn on. This causes the water to flow from the tank to the sink. In this phase, the water level in the tank go lower and lower. When it reaches the minimum level, the system switches to phase 3. In the third phase, both valves have opposite position compared to before. In this configuration, the system takes the cold water from the outside to fill the tank. Once the tank is full, the system goes back to phase 1 and stays in that mode until the water temperature is under control. Before showing you some benchmark, I will show you in details the component that I use and how I put together all the pieces. The valves are three-way valves. That means that I can deviate the flow of the water from point A to B or C. All the components that I bought have connection for 6mm tube. The flow meter will be super useful to make some good benchmark and to record how much water has passed in the circuit and also the speed of the water flow. The water block has been adapted to fit 6mm tube from the factory 10mm. I bought the tank in a famous gaming device store near to my home for $8. It fit 4 liters of water. Inside the tank I will fit 2 water level sensors and 2 temperature sensors. All the components will be driven by a prototype board that I will fit in the HDD slot. This board will take the supply from the PC and through a USB port will send the information to the PC to do the benchmark. I will log some additional information through the software Arduino 64. In this way I can log some information from the SoC, like the CPU power and the CPU temperature. The first test that I did was with the stock intercooler. I started the rendering to have a CPU usage of 100% and just let the test run. In few minutes the temperature reached the maximum of 93 degrees. The temperature fell from 93 degrees only where we stopped the rendering. The CPU had the thermal paste changed just 1 year ago. Then I changed the case because the old one was falling apart. After 2 days I could finally try this Frankenstein cooling system. The first mode that I will try will be the simple closed loop. So we start the rendering, and as I could imagine the temperature started to rise slowly and steady, since there is no radiator and the glass of the tank is also a bad heat conductor. We also have to observe that the ambient temperature is really high. This will change dramatically the result of some of the tests that we will see. After 2 hours of test, the temperature of the water that was coming back from the CPU was reaching a whopping 49.31 degrees, so I decided to stop the test. This is not the best result in the world, but I could expect something like that. I would say that the closed loop will make the job for me. I would be able to use this PC without any water outlet close by. Also, we have to consider that in the daily use, the CPU is far from 100% usage all the time. In this graph, we can also see something quite sad. Thanks to the flow meter, we measure how many liters per minute flow in the circuit. I bought every component of this circuit on AliExpress, and the goal was not to achieve top performance, but to build a funny and cheap cooling system. The pump unfortunately didn't like that much hot water and reduced without any apparent reason the flow of the water from 5 liters per minute to between 2 and 2.5 liters. In the next test, the pump will never give a constant flow of water again. The second test is the open loop, also known as the boring test. In this test, I connected the water circuit to the tap that comes from my water well, and the temperature of the water was 100% steady since the temperature of the water can't rise in this condition. In the second half of the test, I moved the valve of the tap to increase the water flow. Here we can see something interesting. The flow of the water is not so important to cool down a CPU compared to the water temperature. Making the flow 2, 4 or 8 times higher will make us drop just a few degrees on the CPU. Finally, we can try the hybrid mode. I did more than one test in this mode. Let's see what I've got. In the first test, the max temperature that I allowed for the water before taking cold water from the outside was 35 degrees. This would be okay in a winter day, but in this hot summer the ambient temperature was 31 degrees. Every 25 minutes the water comes from outside. The gap between the high level sensor and the low level sensor let exactly 2.05 liters inside the system, while the total capacity of the tank is 4 liters. And this lowered the temperature of the CPU from the maximum of 63.6 to the minimum of 59.2. These abnormal things that you can see at the end is unfortunately a stacked valve. This let the system to go dry and stay like that until I fixed it. I think these valves are not suitable to work with hot water, as the description says normal temperature. In 3.5 hours, we use from outside 18.43 liters of water. If we have to pay that from the tap water, will be 0.31 cent in Italy. For the second test, I raised the threshold to 45 degrees, but in 4 hours I never reached that temperature. Now we could say that the temperature that I set is too high, but what about the first test when I reached 49 degrees in 2 hours? The point is that we can see how much the ambient temperature changed completely the result of the test, and how every time we take a benchmark we should log the ambient temperature as well. In the next test, the water will reach a temperature in 1 hour thanks to the much higher ambient temperature. And for the last test of this video, I wanted to try something else that doesn't make any sense, but I was curious to try honestly. Now the threshold is 10 degrees higher than the ambient temperature, always. This long test started early morning and ended in the afternoon with a big temperature change. The period of time that the system takes to stabilize the temperature now is more similar, even if we are not supposed to care about it, because our final goal should be the temperature of the CPU. Not the water, not how much time we change the water and whatever. This is the end for this video, guys. If you have found some interesting information in this video, consider to like and subscribe. If you think this video was quite boring and bad, consider to like and subscribe anyway, because it's free, so why not?